This is Miss Parody, and this video is all about partial variation. So once again, we're going to take a look at an example to learn about partial variation. The graph below represents the total cost, C, of a taxi fare for a distance D in kilometers. Describe the relationship between the distance driven and the total cost. So if you take a look at the graph, you can tell that it's clearly about the cost of a taxi fare by the title, the dependent axis listing the cost, and the independent axis being the distance. So we know that cost depends on distance. We can see that with a distance of 0, we have a cost of $2, a distance of 2 kilometers, cost of $3, and so on. So in describing this relationship, we say that there's a flat rate or initial fee of $2 to take the taxi. So this is to say that as soon as you get into the taxi, when they start the meter, it starts at $2, not at 0. For each kilometer driven, you're charged an additional 50 cents. So we can see this because as we went up 2 kilometers, we went up $1. Another way that we can figure out this variable cost, or the additional charge per kilometer, so we take two of the points on the line. I arbitrarily chose 6, 5, and 0, 2, and calculate the slope, or the rate of change. In this case, we have y2 minus y1, so 5 minus 2 over 6 minus 0, which gives us 3 over 6, 1/2, or $0.5 per kilometer. Because again, we're calculating the change in cost over the change in distance driven. Part B. Why do you think that this graph does not start at the origin? What does the start point on this graph represent? So we already discussed that in Part A, so just quickly, the graph does not start at the origin because the initial fee is $2. So once again, because before any distance has traveled, we already have an automatic fee of $2. The initial fee is $2, and it will be charged before you begin to travel. How would you represent this relation with an equation? We can't quite look at this example the same as we did with the other example. The dependent variable does not vary directly with the independent variable, but we still do need to express the dependent variable in terms of the independent. The equation I came up with is total cost is equal to 50 cents, or 0.5 of a dollar, per kilometer driven, plus the flat rate of $2. So C, our dependent variable, represents cost. We have our variable cost, which is 0.5, or 50 cents per each kilometer driven. So it's the rate of change times the independent variable plus the fixed cost. Does this situation show direct variation? Explain. There are a number of ways that we can explain why this does not represent direct variation. First, let's look at the graph. Graphically, it does not pass through the origin. When we talked about direct variation, it was very clear that for a variation to be direct, it must pass through the origin. Secondly, if we look at the equation, we know that it does not have the form y equals mx because of this fixed cost. We have dependent is equal to a variable cost, but there's an additional value tacked onto the end that we need to take into consideration with partial variation. So let's recap partial variation. Partial variation is a relationship between two variables in which the dependent variable is the sum of a constant number and a constant multiple of the independent variable. So using words, we say that the dependent variable varies partially with the independent variable, or that y varies partially with x. So graphically, when comparing to direct variation, we still have a straight line, but our straight line does not pass through the origin. It passes through some other point along the y-axis. Algebraically, we have the equation y equals mx plus b. So y equals mx, very similar to the direct variation. The only additional part we have here is the added on initial value or fixed rate. So y still represents our dependent variable. Mx represents our variable rate, or our slope times the independent variable. And b represents our fixed or initial value of y.